Okay, looking at 59 and 61, first I start off with the expression the square root of 18m squared. I can break that into the square root of 18 times the square root of m squared. The square root of 18 can be rewritten as the square root of 9 times the square root of 2, and the square root of m squared is just m. Okay, because the square and the square root cancel each other. The square root of 9 is 3, so we're left with 3 times the square root of 2 times m. And when we write this in finished form, we usually put the square root last. So this would be 3 times m times the square root of 2. Done. Okay, so that's 59. Okay, number 61. Number 61, here I've got 3 square root of 5 minus 8 square root of 7 plus 2 square root of 5 minus the square root of 3. Now all of these are in simplified form already, and the thing we're looking for here is which terms are like terms that we could combine. So we have 3 square root of 5 and 2 square root of 5. Okay, so those are like terms. They both have square root of 5. They both contain the square root of 5 as a common factor within each of those terms. So now we can use distributive property, and we will go 3 plus 2 times the square root of 5 minus 8 square root of 7 minus square root of 3. Combine these two numbers, coefficients, and we have 5 square root of 5 minus 8 square root of 7 minus the square root of 3, and we're done. That is the simplest form that we can get, because none of these are what you consider like terms. None of them have common factors. So that's it. Going on with the next problem. So let's see, after 61 is 62. So number 62, here we're looking at the square root of 48. Square root of 48 minus the square root of 27. So if I can rewrite this now, if I wanted to, I could use my ladder method. We could do that. So 48, let's try that one. So 48, so 2 goes into 48 24 times, 2 goes into 24 12 times, 2 goes into 12 6 times, 2 goes into 6 3 times. So this turns into, the square root of 48 turns into 2 times 2 times 2 times 2 times 3. Well, here I've got a pair of 2's. Here I have a pair of 2's. So the rule is you throw each one of those out, take these to the outside. Right? So we're left with 2 times 2, and inside all we have is 3. So this turns into 4 square root of 3. Okay, 27, let's use the other method for simplifying that. Here I could rewrite this as the square root of 9 times the square root of 3, which is simply 3 square root of 3. So our final expression then would be 4 square root of 3 minus 3 square root of 3. So both have a common factor of square root of 3, so we can just go 4 minus 3 times the square root of 3, which is equal to 1 times the square root of 3, which is equal to just the square root of 3. And that's it for 62. 64, this is probably one of the easiest ones of the bunch. 64, here I have the square root of y plus 5 squared. Y plus 5 quantity squared. Well, the square root and the square cancel, so that's equal to y plus 5. And we're done.